We're doing money, money, money.
Oh, okay.
Okay?
I got you.
Quickly, all right? Okay. And this is really very helpful for y'all. We're talking about college loans, which you probably will maybe take a loan out when you go to college because it's so expensive. But to help with the cost of tuition, room and board, you take out a loan of $20,000 for college. Now, what is tuition? Anybody know?
It's the money. Tuition is
How much it costs to go to school?
That's like the flat cost. That's not like your extra hours or anything.
Okay,
It's
yeah.
not room and board, it's not
Tuition
food.
is how much you pay per hour. So, like, if you take 12 hours, you pay so much per hour, and you multiply that by 12. That's kind of how that works. Okay. Then room is where you live. Board. You know what that is?
Where you live.
Where you eat. It's food. It's your food. Okay.
Oh,
Room and board is like your living expenses. Okay. All right. You don't have to make any payments on the loan until you leave school. However, the loan amount accumulates interest at the rate of 12% annually. Okay. So determine how much you will owe after X years of school. Complete the table and the graph. So we're going to start out. You're going to borrow $20,000. After the first year, you want to find out how much you owe.
You
So.
owe $22,400.
And how'd you get that, Alex?
It's 20,000 times 0.12 times X. Like that's in parentheses times X plus the 20,000.
Okay, you did it that way. Let's just do 20,000 times 0.12. Okay, that's 12% of 20,000 is 2,400. Okay, what does that represent? That $2,400
The extra that they're doing.
extra that you have to pay back. So we're going to have to pay back the extra plus what we borrowed, right? So we add those together. 2,400. Okay, then after year 2, what would we do for year 2? Actually, you got to do 12% of the new amount, which makes it higher, which is okay. And then add that to the 22,400. So we get 25,000. Yep. Okay, and we can continue doing that times 0.12, and then add that to 28,098. Okay, is there a shorter way to do this? Could we multiply by something else that would make it so that we wouldn't have to add it every time?
I don't know.
Okay, let's do this. Let's figure out what we multiplied by to get from 1 to 2.
12.
No, we didn't actually. Let's do 25,088 divided by. No, let's start with the 20 and the 22. 22,400 divided by 20,000. Okay, so the ratio is 1.12. You multiply 20,000 times 1.12, you get 22,400. So we're multiplying by 1.12 every time. Where's the 1 coming from? We know where the 0.12 is.
The 1 is the original 22.
It's the
20, original 20,000, exactly. It's what, and in this case, it's this number. As you go down, it's the new number every time. But it's the part when we had to add, that's the part. Okay. So a little quicker to just multiply by. And I'm just going to round. Well, we can go ahead and leave it. I didn't round very well. I just left it how it was, left off the decimals. But you can round if you want. Since the numbers are so big, it doesn't make a big difference. Okay, now let's graph it. Y'all have all the numbers in there? Okay. Let's graph it. So at 0, 20,000 would be here. These are going up by 5,000, I guess. So 1 and 25,000. Whoops, I forgot 22, didn't I? 3, 25, 4, 28. still saying it wrong. 225, 328. It should be a slight curve. It kind of looks like a straight line, but
It looks like a quadrant.
yeah, but it's really exponential. It's just such large numbers that the curve is real, it's not curving really quickly. Okay, and if you can remember from Tuesday, our formula for the exponential was y equals a times b to the x. Remember that? You remember what a was?
A was where it started.
Where it started. That's right. It's this number right here. And what is b?
B
Is
is
how much it raised.
Yes, the ratio that we multiplied by. So we can write the equation because we know a and b. What is a?
20,000.
20,000. So I'm going to put that over here in this little box, but you have to kind of squeeze it in. Okay, 20,000 times the b, and the b is
1.12.
good. To the,
6.
actually we're just going to put to the x. Okay, because we could put any number of years in there. Okay. And now, everybody understand where that came from? Okay. Suppose after graduating college and or law school, how much would be owed after a total of 8 years? How would you figure that out? Where's the 8 going to go in the equation
F in the end.
for the x?
Oh,
Right? It's for the x, okay? The x represents your years in school. Okay, so we can do 20,000 parentheses 1.12, close your parentheses to the 8th power.
Almost 50,000.
Yeah. Okay, so would you want to take out this loan?
No.
No. After 6 years, it was almost double. Okay, this is a bad loan because the interest rate is way too high. Okay, don't ever do that. Usually for school loans, I think they're around 6 or 7% rather than 12%. Okay, then suppose after graduation you decide on medical school. How much would you be owed after 12 years?
Law school.
Yeah. 77,919. Now, if you did go to these schools, you'd probably have the money to pay for it. But once you got out, got a good job. Okay, domain and range of the problem situation. We're going to let the table help us figure that out. Domain is X or Y? Which one is it, domain?
X.
X. Domain is X. Okay, and X starts at what? Look at here's X. It starts where?
0.
0, because you're starting at the time that you borrow the money. Okay, and it could go on how long? It could go on forever. Okay, so what would you say? X is what? Less than, greater than?
Greater than 0.
Greater than 0. Now, and it's also equal to 0, because at 0 years, it's equal to 20,000. Okay. Now, the range is the money owed, the Y. What does it start at?
20,000.
And it keeps going. So what would you put?
So that's greater than 20,000.
Or equal to? Because you're going to borrow 20,000, you're never going to pay back less than 20,000, aren't you? You have to pay at least 20,000 back. Okay, now the car problem is very similar, except it decreases. As a graduation gift, your grandparents buy you a shiny new car worth $20,000. However, due to wear and tear, the car loses 20% of its value every year. To determine the value of the car after X years, complete the table in the graph. So once again, we're starting at 20,000, but we're losing value. So how would you figure this one out?
20,000 times 1.2.
Okay, you did the 1.2, which is close.
Divided.
Let's do 20% of 20,000. How would you do that? Times 0.2. Okay, changes of 20% to 0.2. So the first year it loses $4,000 in value. So how much is it worth now?
16,000.
Okay, this is how much the car's worth. Okay. Now you were close. Okay. Now we're going to take the 16,000 and multiply by what? 0.2. So now it's worth
Oh, yeah,
3,200
it's
less.
losing, it's
Uh-huh.
not gaining.
So minus 3,200, 12,800. Now let's find the ratio again, like we did up here. 20. Let's do 16,000 divided by 20,000. It's 0.8. Why is it 0.8 instead of?
Because you're losing 0.2.
You're losing 0.2. So you're losing 20%. That means you have how much percent left?
80.
80%. Okay. So it's reducing by 20%, but it's really, so you're taking 80% of the value. Okay. So let's just multiply everything by 0.8 now. How much is it worth after 6 years?
$52.42.
$5,243. Okay. Okay, then we'll graph it. The graph is going by 2,000s, 2,000, 3,000. I mean, 2, 4, 6, 8, like that. So 0, 20,000. 1, 16,000. Yeah, that's
Sometimes more of a curve.
It does. At least I thought it did. It could still look like a straight line too, but it's supposed to be a curve. Okay. Once again, we're going to do y equals a times b to the x. So what is a?
20,000.
20,000. Okay, and b, right? 0.8. Good. To the x. Good. Perfect. Okay. Now, up here we added 1 and got 1.12. Now, down here we're saying 1 minus 0.2. That gives you the 0.8. Okay. So if it's decreasing, you do 1 minus, and if it's increasing, you do 1 plus. So, right. Okay, how much will the car be worth in 10 years? Okay, let's put this one in y equals so we can look at the table. That way we can see several different things. We don't have to keep typing it in. And we'll go to the table, second graph, and look for 10 years.
Something's wrong with my table. It's showing it like.
Oh yeah, it sure is. Okay, you gotta do 20, you gotta put your parentheses like this. Don't put it here. Yeah, put it, because you're not doing that whole thing to the 12.
Yeah.
You're just doing the 0.8 to the 12. Yeah.
Okay.
Okay.
That makes more sense.
Did everybody else get the table? Did y'all get it okay? Chandler, did you get it all right? Okay. So at 10 years, how much is it worth?
2,147.
Yep. Okay. And 25 years?
75.
It's a, how much?
Yeah.
$75.55, right? Do you think it's going to be worth that? No. But one thing about cars is after a long period of time, they actually gain value. Okay. So this model doesn't really account for that. Okay, then according to this function, will the car ever be worth absolutely nothing? This function is going down towards 0, but it's never going to touch 0. So it will never be worth nothing. You're going to take 80% of it every time, so you always have something left. Okay, now the domain, what can x be?
It is greater than or equal to 0.
Yes, good. And the range,
Less than or equal to 20,000.
okay. Except, what did we say? It can't be 0 either, right? So actually what we're going to do is we're going to say that y is between 0 and 20,000. And we can't put an equals next to the 0 because it can't equal 0. So that would be the range. Okay, then the next part is the growth and decay. It's in your notes, and that's what you put on your computer. Okay, and that we did like the very first page and a half or something like that, and then we'll finish the rest of growth and decay tomorrow. Okay. Now y'all can either watch that right now and work on it, or tonight, or however you want to do that.